Hi everyone, my name is Emmanuel Chauke. So in this video I'll be teaching how to solve Clairaut equation. So let me write it down. Clairaut equation. So in Clairaut equation we mean that we're going to dwell much on differentiation, and I'm assuming that you know differentiation from maths 1, that is calculus 1. So those are doing applied maths 2, that is second year in applied math, you'll find it very useful to watch this video. So what we mean by Clairaut equation, we mean that we're going to assume that P is equals to dy over dx. If we can know this, we won't have a problem when we solve the problem itself. So secondly, we need to know the general solution, that is x dy over dx plus f of dy over dx. Mathematically we know that we can write that since dy dx it is equals to p, wherever I see dy dx I'm going to replace by p. So in short we'll have xp, because this is p, plus f of p. This is the general solution or a similar solution. So always when we are given a problem, we need to leave it in terms of x and y. So what we mean is in this Clairaut equation, we're going to solve different problem here. Like let's say maybe they say solve the following. Solve the following Clairaut equation. Solve the following Clairaut equation and find the general solution. Find the general solution and singular solution So let us check the problem itself now. Let us check the problem. Now. It's very easy. Let me just write example 1. Let's say maybe you're given x is equals to px plus 1 over p. I told you from the beginning of time that, you see, whenever you're given a problem you must be very careful with differential equation, and that is firstly I'm assuming that everyone knows how to differentiate. So if we were to differentiate this with respect to with respect to x, with respect to x, we know from calculus 1 or first year that we can use implicit differentiation. That is a rule. When we differentiate px in terms of x or with respect to x, we're going to get p. This is a product rule, but we're going to use implicity. So I'm going to say x the p over the x. When I differentiate 1 over p with respect to x, I'm going to get minus 1 over p squared the p over the x. But what we know is that p P is equals to dy over dx. Meaning, whenever I see dy over dx, I'm going to put P. Now let us look at that. So since this is equals to P, I'm going to say that the P over dx minus 1 over P squared the P over dx. So you see, if I bring this P to that side or this to that side, I'll have 0 on the left hand side then. So in short, I'll have x dp over dx minus 1 over P squared dp over dx is equal to 0. Since I can see a common factor of dp over dx, I can figure it out. dp over dx is equal to x minus 1 over P squared is equal to 0. Then therefore dp over dx is equal to 0, or x 1 over P squared is equal to 0. And then if I were to use integration here to find the P, I will just use a separable equation from applied maths 2 first semester. We know that differential equation. So I will just say dp is equal to the integral of 0 then dx. So it means that I'm going to have P. When I integrate dp, I'm going to get P. When I integrate 0 with respect to it, I'm going to get C. It's a constant, don't forget that from S1. And then here, when I transpose that, I'm going to have that. Don't forget, the goal is to solve for P. So I'm not going to dwell much on that, because you know, when we solve for P in this case here, we're going to have plus or minus 1 over the square root of x. So now we have P, the general solution, because we are given that y is equal to px plus 1 over P. Then we can just say the general solution is y is equal, if I see P, I'm going to put C. So C x plus 1 over C, general solution. Or because you see P is equal to that as well, y is equal to, I'm going to take the positive there, don't take the minus because we have a problem. So I'm going to say 1 over the square root of x, 1 over the square root of x multiplied by x plus 1 over P. So P is 1 over the square root of x there. Now don't forget that our equation must be in terms of y and x only. So it means that I will solve this equation to see how far I can go with this simplification. Don't forget that we have y is equal to x over the square root of x plus 1 over 1 over the square root of x. Mathematically, this can be written as the square root of x, x over the square root of x plus the square root of x when we take the reciprocal of that. So this implies that y, it is equals to, when I take the LCD of that, it's going to be square root of x, this will be x, plus, you see here, you need to be very careful here, I'm going to have x. This will simplify itself to 2x over square root of x. So you can go further on. You see, when you were in high school, you learned about rationalizing the denominator, of which in this case it will be very easy to rationalize that, because I'm going to assume that you know how to simplify this. You're going to multiply by the conjugate of the square root of x there, of which will be, you can go further on solving that. So you're going to have that when you simplify that out. Therefore y is equals to that. So if I want to put it clearly, I will square both sides, and that will be 4x. So thus the singular solution will be y squared minus 4x equals to 0. And then thus the singular solution for the given problem is given by y squared minus 4x is equals to 0. So you can leave your answer there. So this is your general solution. Earlier on you found your general solution, so we call this a singular solution. So you can go on check on my videos on Clairaut equation, so I will be solving example 2. So yeah, I'll see you there.